Good morning, students. Today we will study about the electric field intensity due to a uniformly charged spherical shell. Consider a thin spherical shell of radius capital R with center O. Let charge positive Q be distributed uniformly over the surface of the shell. Now we will calculate the electric field intensity at a point P at a distance small r from the center of the shell. It means this point P is outside the shell. So we will find the field outside the shell. Now draw a Gaussian surface S1 around the point P. To calculate the electric field, we will use the Gauss theorem. According to Gauss theorem, this EDS is equal to Q by epsilon naught. Now EDS cos theta is equal to Q by epsilon naught, or this E closed surface d cos theta is equal to Q by epsilon naught. Now this is the ds over the small area over the surface, but we want to complete area. So the area of this is the small surface area of the sphere, and for the complete sphere this is 4 pi r square. We will take the radius of the Gaussian surface, and this theta is equal to 0 as perpendicular over the surface and the electric field are in the same direction. So this theta is 0 and cos 0 is 1. So this E 4 pi r square is equal to Q by epsilon naught, or this E is equal to Q upon 4 pi r square epsilon naught, or Q by 4 pi epsilon naught r square. Now this is exactly the field produced by a charge placed at the center O. Hence, we conclude that for points outside the spherical shell, the field due to the shell is same as the field due to the point charge, or we can say that the shell behaves as if the entire charge is concentrated at its center. Now the second case. Now if we have the same surface, same sphere of radius r, now we are decreasing the distance from r towards the center, towards the sphere. When we reaches over the surface of the shell, it means this point P is over the shell. When this point P is over the surface, it means this is the same Gaussian surface. It means this small r is equal to capital R, or E is equal to Q by 4 pi epsilon naught capital R square. It means this E is inversely proportional to R square, and this is the maximum value of electric field intensity over the surface. If sigma is the surface charge density, then Q is equal to sigma into 4 pi r square, or this E is equal to sigma 4 pi r square upon 4 pi epsilon naught r square, or cancelling these two values we get sigma by epsilon naught. This is the value on the surface of the spherical shell. Now third case, when this point P is inside the spherical shell. See, point P is here, and this is the charge distributed uniformly over the surface of the shell. The radius of the shell is r, but now we are considering the point P inside it. Let it be small r, at a distance small r from the center of the shell. Now this small r is less than capital R. Electric flux through the Gaussian surface is equal to E into 4 pi r square. Now as there is no charge inside the Gaussian, surface, so this E is equal to Q by 4 pi epsilon naught r square. In this case, when charge is 0, so it means electric field intensity is also 0. It means inside the shell at all the points, if the point is very close to the center or near the surface of the shell inside the sphere, inside this spherical shell, the electric field intensity is 0. Now we will discuss example. S1 and S2 are two concentric spheres. S1 and S2 are two concentric spheres enclosing charges Q and 2Q respectively as shown in this figure. Now what is the ratio of electric flux through S1 and S2? Now S1 encloses only the charge Q. So by the Gauss theorem, this flux is equal to the charge over the epsilon naught. For the surface S2, this charge Q also resides over a surface, so the total charge over the surface S2 is 2Q plus Q. So this is 3Q by epsilon naught. Now we have to find the ratio. So Q1 by Q2, dividing this, we will get 1:3. Now the second part, how will the electric flux through the sphere S1 change if the medium of dielectric constant K is introduced in the space S1 in place of air? Now we know that the dielectric constant K has the relation, this K is equal to E by E dash. E means when electric field in air upon the electric field when some medium is introduced. Now the flux will change. So phi is equal to E ds. This is by the definition. And this E dash will be replaced by E by K. And this ds. Again this E ds by the Gauss theorem is equal to Q by epsilon naught and 1 upon K. So the flux changes on the introduction of or introducing air in place of air between the surface of S1. Now the third part, how will the electric flux through the sphere S1 change if the medium of dielectric constant K is introduced between the space S2? It means in place of air, we have introduced some medium, and what will be its effect on the surface of S1? Now S1 will have no effect because we have introduced this medium in the place between S1 and S2. So it will have no effect or there is no change in the flux.